By virtue of the authority entrusted to me, I hereby constitute this assembly as a legal congregation of the University of Pretoria. During this assembly, degrees with all associated rights and privileges will be conferred on the candidate whose names appear in the program. Please be seated. Ladies and gentlemen, we request you to join us in a silent prayer or meditation to give thanks for the achievements of our graduates today. Thank you. Good morning, ladies and gentlemen. I wish you a warm welcome to this graduation ceremony of the University of Pretoria's Faculty of Engineering, Built Environment and Information Technology. And in particular, I wish to welcome the Deputy Dean, Professor Yelov, Mr. Meller, the Deputy Director, who is standing in for the Registrar, chairpersons of schools, heads of departments, directors, emeriti and honorary professors, and all lecturers and their spouses. I also wish to welcome the Student Representative Council, who will be here to present academic honors, and all persons to whom degrees will be conferred this morning, all spouses, parents, friends, and dignitaries who are with us this morning. There is an added touch of excitement as this first group of graduates for the 2019 spring graduation ceremonies await the moment they can walk across the stage, and along with the start of a new month and a new season, today is the ceremonial new beginning of each person who will walk away with their graduation certificate in hand. It is truly a thrilling and momentous occasion for all of you, and us as well. During this auspicious event, 187 degrees, including 14 doctorates and many master's degrees and bachelors, will be conferred on worthy graduates. This high number of postgraduate qualifications is in line with our strategic goal to focus on postgraduate education, thereby striving to improve our international standing as a university. Postgraduate outputs and throughputs are a very important measure of success for us. I'm pleased to report that the University of Pretoria significantly improved its competitive position in the latest 2019 academic ranking of world universities released by the Shanghai Ranking Consultancy. The aim of improving our ranking as a university is to ensure that we provide ever-improving, high-quality education, cutting-edge knowledge, and world-class research solutions to transform lives in communities and the whole sectors of our society and our continent and the world. And in the EBIT faculty, we currently have no less than 13 NRF-rated researchers. And this is indicative of the quality of academic offering at this university, and particularly in this faculty. Our teaching and research staff are recognized for excellence and innovation. And of course, there is a lot of work happening in the community as well that make an impact apart from the teaching, and particularly in the industry, which is driving what is commonly known as digital transformation. And being cutting edge is the name of the game at UP. And another important measure in the ranking of the university is our international profile. Ladies and gentlemen, internationalization forms part of our strategic goals again, in addition to postgraduate education. And this contributes to higher standing and rankings to become one of the world-class universities. And in the bigger scheme of things, universities worldwide strive for research excellence, diverse student populations, a solid reputation, academics with international acclaim, and collaborations across the globe. At UP, and in this faculty in particular, we continue to make massive strides in this regard. And this is not only true to our staff, but also our students. And in April of 2019, just about 5 months ago, a PhD student in this faculty, Mr. Patrick Sekhoba, received International Professional Award at the SAS Global Forum in Dallas, Texas, for his research in the area of data science. He was honored along with 14 other professionals from countries such as the United States of America, India, Canada, Brazil, Japan, Poland, and the UK. I must point out that the University of Pretoria is not only concerned about what happens in the classroom. We firmly believe that a vibrant student life is essential for personal growth and wellness, as well as professional development of our students. Ultimately, it is about more than just producing employable graduates, which this faculty does incredibly well, but also about cultivating a sense of responsible citizenship and well-rounded character in our graduates. In a nutshell, this is your opportunity to start building your legacy if you haven't done it already. It is therefore inspiring to hear of the outstanding achievement of students in the faculty in culture, sport, and community. One of our younger graduates, undergraduate students, recently excelled in sports by winning the South African slalom ski titles at Tiffendale in the Eastern Cape in July this year. And she was skiing down a slope of no less than 2,860 meters at high speed, displaying great skill, concentration, and bravery. I'm too old to do that. After putting in her required hours behind the books, Ms. Elizabeth Olivier still makes time to practice her sport to the extent that she has represented South Africa at the Youth Olympics and the World Championships. This is but one example of the many talented individuals who are enrolled in this faculty. They don't just focus on engineering or built environment or IT. They focus on other fulfilling exercises such as culture and sport. And these students are proof that achievement is talent plus preparation. And no accomplishment comes without hard work. But this morning is about our graduates. It is about your hard work, your achievement, your reward, your sacrifice, your compassion, It's about the love of engineering. I wish to extend congratulations from our Chancellor, Professor Nkutlu, and our Vice Chancellor, Professor Kupe, and all our executive team members to the graduating class. Along with the Dean and Deputy Dean and staff in the faculty, we are truly delighted with your remarkable achievement. Please accept our heartfelt congratulations for achieving this milestone. The opportunity that you have had at this university and the support that you received from everyone is testimony to the fact that you will leave this university, those who will be leaving and those who will be staying and studying further or working will actually be able to make a difference in the lives of many people. While we celebrate your achievement, it is fitting that we should also give recognition to those who have supported you throughout your studies. Whether it was academically or financially, and we know financial resources are very, very scarce, or emotionally, because as you go through these intense programs, you become emotionally drained and you need support from different quarters. And here I'm referring to your supervisors, your lecturers, your mentors, your tutors, your librarians, administrators in the faculty and elsewhere, assistants, parents, spouses, family, friends, and of course partners, sponsors, and of course your significant others. And these people have actually made a huge difference in your lives and actually contributed to your success today. And your support through the course of the degree is sincerely appreciated. Can we give them a round of applause, please? And in conclusion, may your UP qualifications and the lessons you have learned at UP, both inside and outside the classroom, continue to empower you to play a constructive role in society. May you rise out above the rest in your fields of specialization, but also in various roles in your professional and personal and community circles. Attaining a university degree, ladies and gentlemen, is actually something that has become a necessity, if you like, especially given the changes that we have in the world, and particularly with the threats that are coming up with digital transformation. And this faculty is well placed to actually make that difference and be able to take us forward. We know that we are producing engineers and scientists of note. All that remains, therefore, is for me to wish you well as you start the new chapters in your lives. And as you do, I know engineers make a lot of money, so I know that. I'm much poorer than engineers. So when you start making money, please remember us at the University of Pretoria. We have what we call the alumni, we have needy students, some of you have gone through this. So we can only do it together in collaboration with you to actually make contributions that can take us forward. This university is very efficiently run. We don't, misappropriate resources, especially scarce resources. So if by any chance you begin to make a little bit of money, please remember us. Thank you very much. I will now request the Deputy Dean to introduce to me the candidates present whose names appear in the program.
Mr. Vice Principal, the supervisors will now introduce the doctoral candidates.
Mr. Vice Principal, I introduce to you John Kabangu Mpega, who has complied with the requirements of the degree Doctor of Philosophy in Chemical Engineering with a thesis titled Extraction and Separation of Zirconium and Hafnium Using Octanol, prepared under the supervision of myself and Dr. Salmon Libber as co-supervisor. Zirconium and hafnium metals have drawn considerable attention due to their various applications, particularly in the nuclear industry. Conventional extractants used for the withdrawal and separation of these two metals presents several technological and environmental problems. In his thesis, Extraction and Separation of Zirconium and Hafnium Using Octanol, the promovendus proposed a new method, namely the use of octanol as an alternative extractant. The process is economically viable and environmentally friendly compared with conventional extractants such as methyl isobutyl ketone, tributyl phosphate, and high molecular weight tertiary alkyl amines. The results indicate the possibility of producing higher purity zirconium and hafnium oxide, which can be used in the production and manufacture of nuclear grade zirconium and hafnium, starting with typical zirconium-rich ore or concentrate. The use of octanol as an extractant presents both a direct advantage by reducing the cost of the process and an indirect advantage by the avoidance of environmental problems. Mr. Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Antonio Benjamin Maposa, who has complied with the requirements for the degree Doctor of Philosophy in Chemical Technology with a thesis titled Slow Release of Mosquito Repellents from Microporous Polyolefin Strands, prepared under the supervision of Professor Walter Fokker. Malaria is a principal cause of illness and death in countries where the disease is endemic. The World Health Organization recommends indoor residual spray of insecticides and the use of long-lasting insecticide-treated bed nets as practical methods for the prevention of malaria. However, current malaria prevention methods do not protect against mosquitoes biting outdoors, hampering the elimination of malaria. In this thesis, Slow Release of Mosquito Repellents from Microporous Polyolefin Strands, the promovendus explored the possibility of making long-lasting mosquito repellent bracelets and anklets. Highly effective insect repellents were incorporated into inexpensive thermoplastic polymer strands via extrusion compounding. In the process, a membrane-like surface cover formed that controlled the release of the repellent trapped inside the strands. Bioassays indicated that the strands containing up to 30% of either DEET or icaridin provided effective protection against mosquito bites even after 12 weeks of aging at 50 degrees centigrade. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Shogo Mayokan Abularan, who has complied with the requirements for the degree Doctor of Philosophy in Mechanical Engineering, with a thesis entitled Heat Transfer and Pressure Drop Characteristics in a Transitional Flow Regime with Twisted Tape Inserts, prepared under the supervision of Professor J.P. Mayer and myself as co-supervisor. The transitional flow regime that would normally produce a good compromise between laminar and turbulent flow is avoided because of predictions that are complicated and characterized by different transport phenomena. In his thesis, the promovendus identified the transitional flow regime in a tube equipped with conventional clockwise and counterclockwise and peripheral U-cut twister tape inserts. The results revealed that the transitional flow regime could be accurately identified using the standard deviation and linear line techniques developed in the study. The start, end, and enhancement of the heat transfer and pressure drop characteristics in the transitional flow regime were significantly affected by twist ratios, free convection effects, connection angles, depth ratios, and ring space ratios of the twisted tape inserts. The techniques and correlations developed provide valuable tools for design and operation of enhanced tube heat exchangers. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Wilhelmina Ludovica Bean, a wife, a mother, and a scholar, who has complied with the requirements for the degree Doctor of Philosophy in Industrial Engineering with a thesis titled Behavioral Modeling of Carrier and Receiver Collaboration in an Agent-Based Urban Transport Simulation, prepared under my supervision. With urban densification comes high consumption. Everyone wants fresh produce at their local retail outlet, yet they don't want to see trucks on the roads. In her thesis, the promovenda showed that the negotiations between freight receivers and carriers are quite complex and directly manifest itself in the price payable for the goods on the shelf. The promovenda modeled the relationships between carriers and receivers using game theory and embedded the behaviorally rich model into the multi-agent transport simulation platform called Anthem. After rigorous and systematic testing, the model was applied to a case study in the city of Cape Town, illustrating the value, both the impact and the benefits of collaboration for after-hour deliveries. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Daniel Rafael Evim, who has complied with the requirements for the degree Doctor of Philosophy in Mechanical Engineering with a thesis titled Condensation Inside Horizontal and Inclined Smooth Tubes at Low Mass Fluxes, prepared under the supervision of myself. To date, no study has systematically investigated the influence of temperature difference, vapor quality and inclination on the heat transfer coefficients and pressure drops during condensation. In his thesis, the promovendus performed novel experiments to improve the fundamental understanding of the two-phase flow behavior at low mass fluxes by investigating the heat transfer, flow patterns and pressure drop characteristics during condensation inside horizontal and inclined smooth tubes. Experiments were conducted and an extensive database of pressure drops, temperatures and flow regimes were compiled. The main contribution of this study is a modified correlation for predicting heat transfer coefficients at low mass fluxes and the determination of the inclination angles that led to increased heat transfer. Using the new correlation and angles, more efficient heat exchangers can now be designed. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Right. Mr. Vice Principal, I introduce to you Brilliant Habinzu, who has complied with the requirements for the degree Doctor of Philosophy in Electronic Engineering with a thesis entitled TID-Induced Small Signal Model Variation in CMOS and SIGI by CMOS, prepared under the supervision of myself and Professor Walter Meyer as co-supervisor. There has been an increased interest in space-based communication applications in the millimeter wave frequency band from 30 to 300 gigahertz. Space-based systems are, however, exposed to ionizing radiation, which degrades the small signal parameters for microelectronics at a device level and can lead to system failure. Accurate prediction of the degradation of small signal parameters in transistors at millimeter wave frequencies is therefore important in determining the lifespan of microelectronic circuits operating in ionizing radiation environments at millimeter wave frequencies. In his thesis, TID-induced small signal model variation in CMOS and SIGI by CMOS, adaptive model parameters were derived from experimental data that relate the degradation of small signal characteristics of silicon germanium heterojunction bipolar transistors and bulk complementary metal oxide semiconductor devices at millimeter wave frequencies to total ionizing dose damage. The work paves the way for predictive modeling of millimeter wave transceiver degradation in space. Mr. Vice Principal, I request you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Andre Unudia, who has complied with the requirements of the degree in Doctor of Philosophy in Chemical Engineering with a thesis titled Fumaric and Malic Acid Production with Immobilized Rhizopus oryzae, prepared under the supervision of myself. Chemicals derived from renewable feedstocks must gradually replace fossil-derived counterparts to ensure future sustainability. Fumaric and malic acids are bio-based alternatives which can be used to displace petrochemically derived butane as a source of maleic anhydride, a high-throughput bulk chemical. In these theses, fumaric and malic acid production with immobilized Rhizopus oryzae, the promovendus proposed a novel method for producing fumaric and malic acids using an immobilized form of the fungus Rhizopus oryzae. A new framework for continuous operation was developed, resulting in the highest fumaric acid yields reported in the literature, through the use of a novel nitrogen control strategy. The work is a major contribution in the field of bioproduction of 4-carbon dicarboxylic acids. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Mutahir Olawase Oloyede, who has complied with the requirements for the degree Doctor of Philosophy in Computer Engineering with the thesis titled A Novel Face Recognition System in Unconstrained Environments Using a Convolutional Neural Network, prepared under the supervision of Professor G.P. Hanke and myself as co-supervisor. In this thesis, the promovendus proposed a novel meta-heuristic algorithm-based image enhancement technique as a pre-processing approach for a face recognition system in unconstrained environments. A new evaluation function was developed in conjunction with meta-heuristic-based optimization algorithms to automatically select the best enhanced face image based on a linear combination of different quantitative measures. To avoid selection of images which are too dark or too bright, a defined scale mechanism was designed within the evaluation function to evaluate the enhanced images. In addition, a selection of new hybrid features extracted from the enhanced facial image were presented to improve recognition performance. The results obtained from the experiments on standard face data sets confirmed the effectiveness of the approach to face recognition in unconstrained environments using the convolutional neural network. Mr. Vice Principal, I request you to confer the degree on the candidates.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Stephen Oyawobi, who has complied with the requirement for the degree Doctor of Philosophy in Electrical Engineering, with a thesis title, Development of Spectrum Hand of Protocols with Efficient Channel Selection Strategy for Industry Wireless Communication, prepared under the supervision of Dr. Hanke and myself as co-supervisor. A shortage of frequency spectrum caused by a static access technique is a serious challenge in the deployment of wireless technology for industrial wireless communication. In his thesis, the promovendus proposed a novel access technique that ensures fair allocation of resources for diverse nodes competing for resources. Spectrum hand of protocols were developed using unified spectrum sensing technique, integrated preemptive and non-preemptive priority scheme, and channel selection strategy based on reinforcement learning. Additional spectrum prospects were identified using proactive sensing, a likelihood estimation method, and reinforcement learning. To improve spectrum utilization efficiency, an algorithm that allocates channel according to the priority of user quality of service requirement was implemented. The results show significant performance improvement in terms of number of spectrum handoff, latency, and throughput for industrial application in comparison to other schemes. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Jacobus Gideon van der Westhuizen, who has complied with the requirements for the degree Doctor of Philosophy in Electronic Engineering, with a thesis titled The Role of the Reference Source in Improving the CIE Color Rendering Index for Visual Perception Optimization, prepared under the supervision of Professor F.W. Leuschner. In this thesis, the promovendus described the development and implementation of an alternative method for the measurement of human color perception. Psychophysical color perception tests involving 2 age groups were completed. The results showed that the white perception
of the two age groups was different, but that color perception of humans is remarkably consistent across age. The promovendus came to the conclusion that the age of human observers should be considered when specifying an improved reference source for CIE color rendering. The new method for testing color perception proved to be a viable alternative in situations where dark rooms are not readily available and when side bias needs to be minimized. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all the associated rights and privileges of the candidate.
Mr. Vice Principal, I introduce to you Johan Willy Viljoen, who has complied with the requirements for the degree Doctor of Philosophy in Electronic Engineering with a thesis titled Modeling the Pathogenesis of Cystic Fibrosis and Other Monogenic Variations and the Occurrence of Causative Variants, prepared under the supervision of Professor J.P. de Villiers and Professor M. Pepper as co-supervisor. In his thesis, the promovendus proposed modeling deleterious recessive monogenic autosomal conditions both in individuals for diagnostic purposes and in large populations to investigate the establishment, dispersion, and equilibrium behavior of alleles. Bayesian data fusion techniques were applied, and analytical and statistical stochastic approaches were used to model and predict the dispersion of mutations through large populations, taking into account the cognitive upper level on stable social human relationships. This model accurately replicated observed homozygous disease prevalence levels, indicated a significant overestimation in commonly assumed carrier incident levels, and also determined the magnitude of the heterozygous selective advantage without requiring prior information regarding its phenotypic manifestation. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Shagun Olatunbosun Olatimru, who has complied with the requirements for the degree Doctor of Philosophy in Computer Engineering with a thesis entitled Efficient Energy Resource Management for Water Quality Sensor Networks, prepared under my supervision. The importance of water to life is incontrovertible, and consequently, water quality monitoring is a critical area of research. Wireless sensor network systems provide promising solutions in water quality monitoring applications, but have long-standing issues such as energy scarcity and energy consumption challenges. These have limited their widespread deployment. An energy provision strategy using radio frequency energy harvesting and novel energy utilization optimization schemes was proposed by the promovendus in his thesis. Based on the developed solutions, wireless sensor network systems to monitor water quality were extensively analyzed, evaluated, and compared with the existing state-of-the-art to investigate their performance gains. The obtained results reveal the efficiency of the newly proposed systems in terms of energy utilization, sustainability, throughput efficiency, and resource allocation fairness. Mr. Vice Principal, I request that you confer the degree to the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Nicholas Robert Osner, who has complied with the requirements for the degree of Doctor of Philosophy in Electronic Engineering with a thesis titled Countermeasure Allocation and Loadout Optimization, prepared under the supervision of myself. Electronic warfare deals with the use of the electromagnetic spectrum, which includes radio waves, infrared, optics, UV, and as I think we all know, the electromagnetic spectrum is becoming increasingly congested, very heavily used, making it difficult to operate in this region. The same is true in the military domain. Depending on the model, the Gripen fighters have up to 3 jammers on them. The Eurofighter has at least 2, and the aircraft with even more. One can then move into an environment where you're encountering multiple radars and threats at the same time. And this whole scenario has become such a mess, human beings can no longer make sense of it. So the question that the Provamendis has evaluated is, can we get machines to do a better job of this? And this work involved building a simplified model of this mess, and then getting a machine algorithm to make sense of it, to conduct planning in a way that made sense and produced mission plans that were actually reasonable. The success of these results and the diversity of the work is shown by the fact that the external examiners include specialists in radar and machine learning, someone in the field of operations research, and someone who's conducted major or led major projects for the UK Ministry of Defence. The work also received complimentary comments from one of the senior admirals in the South African Navy, so rather than being just a theoretical work, this work has very definite practical applications. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all the associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Willem de Tooy Malan, who has complied with the requirements for the degree Doctor of Philosophy in Metallurgical Engineering, with a thesis titled Phase Equilibria and Thermodynamic Evaluation of the Iron, Titanium, Vanadium, Oxygen System in Air, prepared under my supervision, with Professors Pekka Taskinen and Guven Abdugan as co-supervisors. South Africa possesses a significant vanadium-containing ore reserves in the Bushveld igneous complex. These materials are of strategic significance, especially due to the increasing importance of vanadium for green energy storage. Vanadium is extracted from titaniferous magnetite ores via a number of process routes. A lack of data for vanadium-containing oxide solutions in literature and in thermodynamic databases has been making it impossible to study vanadium extraction processes with thermochemical calculations. For his thesis, Phase Equilibria and Thermodynamic Evaluation of the Iron, Titanium, Vanadium, Oxygen System in Air, the Provamendis therefore studied the said system experimentally by high temperature equilibrium and quench, scanning electron microscopy and microprobe analysis. Phase transition temperatures and compositions were determined and compared with previously published data. The resulting data were then used to calibrate models to describe solid and liquid solutions and stoichiometric phases. The results from his study have been incorporated into commercial thermodynamic databases to improve our ability to study, improve, and develop new vanadium extraction processes. Mr. Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Chemical Engineering. Deveshni Mutli. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Computer Engineering, Damien de Aruda, with distinction. William Green, with distinction. Hardus Richter, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Electrical Engineering, Nge Velekwa, Konjeni Nge Velekwa. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Electronic Engineering, Shanae Pieterse. Wade Smith, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Environmental Engineering. Maria Ristov, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Geotechnical Engineering. Catherine Purchase, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Mechanical Engineering. Ryan Kopp. Leon Brits, with distinction. Philippe Feldesi, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Metallurgical Engineering. Dion de Beer. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Microelectronic Engineering. James Smith. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Engineering in Structural Engineering. Tulani Mulwana with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Bioengineering. Max Dittmar. Stefan van der Merwe. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Chemical Engineering. Nokutula Nslabeng. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Computer Engineering. August Nodia with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Electrical Engineering. Christopher Borerwe. Petrus de Kok. Onkopotse Liu. Shao Pinar. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Electronic Engineering. Gert Klaassen. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Environmental Engineering. Lucky Mogashana with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Industrial Engineering. Armand Erasmus. Lauren Christopher with distinction. Julian Kauper. Murendeni Nematone. Martin Reinders. Armand Rousseau. Kabelo Sitole. Tabiso Titizi. Werner van Nicker with distinction. Martinez van Staden. Henry Wilson. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Mechanical Engineering, Lindilwe Mhlongo. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Metallurgical Engineering, Esmery Skippers. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Metallurgical Engineering, Welding Engineering, Zozele Mkhobo. De Wet van die Kerk. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours in Water Utilization Engineering, Sipiwe Dlamini. Samuel Mapisa. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science Chemical Technology, Bongikosi Nkabane. Danasha Munsami. Sharon Rachotsi. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours, Applied Science in Industrial Systems. Sipumelele Ntlechi. Pardon? The following candidates have complied to the requirements for the degree Bachelor of Science Honours, Applied Science, Industrial Systems, Kiki Lehode. Kupano Charlotte. Sivongivi Tafane. Wezi Banda. Prudence Mabasu. Kenneth Matsenene. Michael Muhai. Pelukazi Modise. Motsatsi Mosechetege. Matthews Motsui. Mukore Mugeri. Sibusiso Nkosi. Ephraim Setsiba. Urabile Talam. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science, Honours, Applied Science in Mechanics. Andrew Baloy. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science, Honours in Applied Science Metallurgy. Lenise Jacobs. Walter Musoma. Philemon Setele. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, Water Utilization. Palesa Mafisa. Koketsu Masemole. Zama Ngwenya. Retabile Lamola. Nomvula Magagula. Mpo Malepe. Tandeka Matsenhuke. Sibongile Nsalazi. Mr. Vice Principal, the following candidates have complied with all the requirements of the degree Bachelor of Engineering in Chemical Engineering. Lindelwa Dlamini. John Newman. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering, Civil Engineering, Rebetse Malatse. Joan Mine. Moloko Mokhakong. Fatego Motiane. Masila Pilele. Mochiburi Ranghata. Okay. Askan Sonakis. Johanne van der Merwe. Mariska Wessels. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Computer Engineering, Johan O'Connell. Dylan Pretorius. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Electrical Engineering, Peter Conradi. Ayanda Nkomo. Dewald van Tonder. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Electronic Engineering, Nicolas Kutsier. Hermanus Stolz. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Mechanical Engineering. Talika Andy. Samo Kelesiwe Bembe. Altus Bischoff. Owen Bondi. Itmelson Carroll. Mamelo Chauke. Shay DeMont. Divan Deval. Christy Flaxman. Benjamin Ho. Wade Jackson. Jahil Jacobs. Vincent Jordan. Luwandu Keti. Branko Kostik. Tyron Labiskachny. Juan Yu Lai. Lekhala Mabalane. Tinu Mutenda Mavuva. Ndumiso Magagula. Dr. Malachi. Homotso Mamanyani. Samora Mashele. Tsembane Masanganyani. Nakeri Matutoka. Tatu Mulapu. Moses Mukhale. Teboho Mpele. Marcus Miller. Michael Muwazi Kakata. Sachin Naran. Sachin Nashar. Siswizake Ngwenya. Yetro Nia Mukunda. Zacharias Oberholzer. Tsepo Pakisi. Henriette Schreiber. Lloyd Singane. Erwin Sivela. Rachel Stein. Tian Swartz. Mornay van Biljoen. Pieter van Wyk. Mark Woods. Gideon Seeman. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Metallurgical Engineering. Victoria Dube. Karabu Shlongwane. Ayanda Madolo. Tadiwa Manzungu. Abraham Masenya. Rovi Ningo Mawuntla. Regi Mfono. Sipiwe Nkabinde. Msanwe Takalu. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Mining Engineering, Ernest Mumedi. Lily Nell.
Ladies and gentlemen, let us give our graduates a big hand for their hard work and thank you. At this stage, I would like to ask all our graduates to applaud their families, friends, and spouses for the support over the years. Thank you. I see those who didn't graduate also applauded. This is legal. This is very serious. Thank you very much. I believe that our graduates, you know that you are the trailblazers. You know that the future of humanity is in your hands in terms of the skills and the high-level training that you have received at this university. And please make us proud. Now, we have now come to the end of the proceedings, and before we close, I would also wish to invite you for refreshments afterwards at the foyer out here of the aula. And at this moment, I would like you to stand for the singing of the national anthem and remain standing until the assembly has been dissolved and the academic procession has left the auditorium. Those of you who still need to learn the words of the national anthem, they are at the back cover of the program. Thank you.
Eternal, so yet
By virtue of the authority entrusted to me, I hereby dissolve this assembly of the University of Pretoria. Thank you.